Hey everybody, this lesson's on acute, right, or obtuse triangles, and it deals with the Pythagorean theorem. Okay, so let's remind ourselves what the Pythagorean theorem is. A squared plus b squared equals c squared. Well, that is when it's a right triangle. But if you don't know what it is, you got to follow these inequality theorems. So if the c squared, which is always the biggest side, if the biggest side squared is greater than a squared plus b squared, then it ends up being an obtuse triangle. If it equals it, then it ends up being a right triangle. Okay, but if it's less than, then it's an acute triangle. So let's try some of these, you guys. And don't forget about the triangle inequality theorem, you guys. That one sneaks up on you every now and then. The sum of two sides has to be greater than the third side, otherwise it's not a triangle at all. Okay, so determine whether the lengths can be a triangle. If so, classify the triangle as acute, right, or obtuse. Okay, so 8, 11, 13. So we got to check out, is it a triangle? And yes, those all fall through, so the triangle inequality theorem says it can make a triangle. So we need to see what's the relationship between 13 squared and 8 squared plus 11 squared. So we get 169 on the left and 64 and 121. And since 169 is greater than 165, it's an obtuse triangle. See, easy, huh? Okay, try this one. 5.8, 9.3, 15.6. Ooh, decimals. You guys freak out with those and fractions. Um, well, first of all, this one becomes up, it's not a problem at all because you end up getting 15.1 when you add them, and that's not greater. So the triangle inequality theorem ensures us it's not even a triangle. Okay, so we're done. We can stop. Okay, so we're going to graph these points right here, A, B, and C, and tell whether the triangle is acute, right, or obtuse. Okay, well, let's graph those guys. Okay, so here's an XY chart, and then there we go, right there, and then it appears like it might be a right triangle right there where AC might be the hypotenuse. So we want to see the relationship with, and I can't just say by picture it looks like a right triangle, and a lot of kids do. They just stop right there. We have a little bit of work to take care of here. You remember distance formula, you guys? That formula right there? Well, since we're squaring a squared with b squared and c squared, then I'm squaring this d. And so when I square this d, all I'm interested in is that part right there, the inside part. I just want to know, I don't need that radical part right there. So here's ac squared. We want to know what's the relationship, because ac looks like it might be the hypotenuse. So when I square it, is it greater than, less than, or equal to? So here's AC squared. I do x sub 2 minus x sub 1 squared, and then y sub 2 minus y sub 1 squared with my a and c. And I end up getting 1 squared plus negative 6 squared, which is ends up being 37. I want to see the relationship between BC, which is 20, and then finally AB, which is 13. And since, you guys, since 37 is greater than 20 plus 13, it's an obtuse triangle.